Let's take a look at how shuffling data across executors can cause problems for a Spark job. I've went ahead and run all on 1.3 shuffle, just so that we don't have to wait for some of these longer running cells to finish. And I want to talk about shuffling. Now, shuffling a lot of times is necessary. What happens is that data partitions get moved from one executor to another, or executor, however you want to pronounce it, which uses network time, right? And essentially makes it so that the job is going to take longer. And in this notebook, we're trying to show you how shuffle takes place, what can cause shuffle, and what we can do or what we can ensure is continuing to be done as far as default configs to make sure that shuffle doesn't happen. First of all, I'm going to disable caching just like I did in the first demo of our course. And I'm going to create some data. Now, again, this is just going to be some dummy data. I have some transactions. I've got an ID, I've got an amount in the transaction, and then I'm going to associate that with some country ID and some store ID, which I'm going to join with a couple of other tables that I'm going to create in just a minute. Now, notice I've got about 150 billion rows that I'm creating here in this table. And I'm going to go ahead and write that to a transactions table. Now let's go ahead and do some stores and some countries. So here's just some random information about stores. They have some ID, and then they have some number of employees, a country ID, and then a name of the store. And again, this is just a UUID, right? I don't know. Maybe this says Walmart, right? I have no idea, but it's just a common store here in the United States. But really what it amounts to is that we just have some data that we can associate with and do a join on to represent some stores. We'll save that as a table called stores. And lastly, let's go ahead and create a table that represents country codes or country IDs and their associated string value of the country name itself. And then we'll save that out as a table called countries. Now I'm going to go ahead and perform a join here. And I want you to note here that there's a couple of new configs here that I've set to essentially be disabled, right? One is auto broadcast join threshold. The other one is adaptive.auto broadcast join threshold. I'm going to set those so essentially they're doing nothing. And this really just shows that if we mess up these default values, we can actually cause shuffle to happen when we don't necessarily need it to happen, when we could do a broadcast join, which can really help solve and alleviate the problem. Let me show you what I mean. Essentially, all we're doing is we are selecting all of these columns from our transactions table. We're going to do a left join to the stores table on the transactions.storeID and the stores.id, and then do a left join on the countries table where we have the transactions.countryID equaling the country.id. And then I'm going to go ahead and save that out to a table called transact countries. Now let's look and see what happened in terms of shuffling. I'm going to go ahead and open up right here where it says Spark Jobs. And what I like to do, I like to open up the first job and the second job, or the last job, I should say. I like to look at the number of stages or the stages that were involved in this particular cell running. I see that I've got 43 through 57. I'm assuming there's some other jobs in here, other stages I should say, but I've got stage 43 to stage 57. So when I open up the Spark UI, I'm looking for that range, 43 to 57. I'll go ahead and open up the Spark UI. I'll go to the Stages tab. And again, I'll scroll down to about where that 43 to 57 range is. I've got 57 up here at the top. I've got 43 over here. And let's scroll over here all the way to the right. We can see here now these last two columns, these are the shuffles that took place. The first one is a shuffle read. The second column is a shuffle write. And we see that within that range of stages that we had in that cell, we can see that we had some serious shuffling going on here, about 1.5 gigs worth of shuffling, whether it be reads, writes, and so forth in a couple of these stages. Apparently two of these, or basically two of these, we needed to shuffle that 1.5 gigs of our 150 million rows of data across the network at the data center, right, from one executor to another to make it so that this can take place. That's not what we want, right? We want things to take less time. Now, here you go. If I look up here, we can see that this took about a minute, 1.14 minutes. And obviously, anytime you have time for a query, this one takes 1 minute. You've got others in a pipeline or others in the notebook that are also taking minutes to run. That's going to just increase the amount of time that it takes to run everything. Now, what happens then if we enable or re-enable our broadcast join? Now, broadcast joins work well when tables that are needing to be broadcast from one executor, right, to all the executors are less than 100 megs, right? So when we see now we've got our relatively small tables, right? Our transactions is a large table, but our stores table is small and our countries table is small. So if we can broadcast those to all the executors and let them use that, we can eliminate those shuffles altogether. And so here we go. So let's go ahead and just enable or unset our broadcast join threshold and our auto broadcast join threshold. We'll unset those so that it's back to the default values. We have the exact same join now. We have now another write to the table. Let's go ahead and open up our Spark jobs. Let's look at the stages involved. 58 to 66. We'll go ahead and open up the Spark UI. We'll go to stages. Let's look now at 58 through 66. I'll just put 66 at the top here. And here's my 58. I'll go ahead and scroll over now and look here. Wow, about 5K, right? Or just a handful of bytes in this case, right? 7K. That's a lot different than 1.5 gigs, right? 7K. And that's just that those tables being broadcast to the executors, right? They just get moved across the network, but that's only 7K. That's going to take a lot less time. And when we look at this query, of course, we see that it did take a lot less time. It took about half the time to make this query happen on 150 billion rows of data. That's pretty cool. And again, this is the default, right? So when we start thinking about how we might adjust and try and tune things, we want to make sure that we are not accidentally causing shuffles or other issues. And also what we should keep in mind is that if we have tables that are less than 100 megabytes, then those broadcast joins are going to happen already. Or if we have a problem where we just can't do that sort of join, we have no ability to fix it, then it may be that maybe we can reorder the task, right, and do it in a different order to make it so that we don't have to act on such large amounts of data. And that's just a workflow issue, right? Sometimes it has to happen, but other times you can do everything you can to alleviate it. Let's look now at aggregations. Now, aggregations do require shuffling in many instances, but generally less expensive. And this cell here is what we can look at here. So this is just a simple aggregation. We're doing a count, star, and we're averaging the amount on our transactions grouped by the country ID. And so let's take a look at how this aggregation took place. I'll go ahead and check out all the stages. We got 67 through 70. We'll go to stages. And 67 through 70, that's the last ones on the list. Here, as we go over here to the last 3 rows, we see that, yep, a handful of bytes here, 5K here. So there is a bit of shuffling, and aggregations are going to take a little bit of shuffling, but there's no way around that, but not nearly as expensive as what we've seen before. Yeah, the query itself took about 4 seconds, right? That's actually quite quickly. And definitely here, the point is, as it says here, that we were only shuffling the counts and sums necessary to compute the counts and averages that were requested, and really just makes it so that a few kilobytes of data are shuffled in Spark, and that's pretty cool. So here you go. Yeah, our output is basically 0 too. That helps quite a bit. But yeah, aggregation's not nearly as expensive, but definitely if you're joining tables together, do keep in mind and try and eliminate shuffle as much as possible.